In this section, we discuss about the isomorphism and matrices of a graph. Definition of an isomorphic graph. Two graphs g1 is equal to v1, x1 and g2 is equal to v2, x2 are said to be isomorphic if there exists a bijection f from v1 to v2 such that u, v are adjacent in g1 if and only if f of u, f of v are adjacent in g2. The map f is called an isomorphism from g1 to g2. For example, there are two graphs A and B such that every pair of vertices which are joined in A are also joined in B. Therefore, this graph is said to be an isomorphic graph. Theorem. Let F be an isomorphism of the graph G1 which is equal to V1, x1 to the graph G2 which is equal to V2, x2. Let V belongs to V1, then degree of is equal to degree of f of V. That is, the isomorphism preserves the degree of vertices. Proof of the theorem. A point U belongs to V1 is adjacent to V in G1 if and only if f of u is adjacent to f of v in G2. Also, f is a bijection. Hence, the number of points in V1 which are adjacent to V is equal to the number of points in V2 which are adjacent to f of V. Hence, degree of v is equal to degree of f of v. Remark. Two isomorphic graphs have the same number of points and the same number of lines. Also, it follows from the above theorem that two isomorphic graphs have an equal number of points with the given degree. However, these conditions are not sufficient to ensure that the two graphs are isomorphic. For example, the two graphs A and B such that have equal number of vertices and edges, but their degree sequence is not equal. Therefore, this graph is said to be a non-isomorphic graph. Definition of an automorphism. An isomorphism of a graph G onto itself is called an automorphism of G. Definition of an adjacency matrix. Let G is equal to V, X be a P, Q graph. Let V is equal to V1, V2 up to Vp. A P cross P matrix A is equal to Aij, where Aij is equal to 1 if Va, Vj are adjacent and 0 otherwise, is called the adjacency matrix of the graph G. For example, we take the graph with the four vertices 0, 1, 2 and 3. We plot them as well as in a row wise as well as column wise. Every vertex is not adjacent to itself. Therefore, the diagonal elements are 0 always. 0 is adjacent to 1, the value is 1. 0 is not adjacent to the 2, the value is 0. 0 is adjacent to 3, the value is 1. 1 is adjacent to 0, the value is 1. 1 is not adjacent to 1, the value is 1. 0 and 1 is adjacent to 2, the value is 1. 1 is not adjacent to 3, the value is 0. Like this, we can plot all other elements in the matrix. So, we get the adjacency matrix for the given graph G. One more example with the vertices, 5 vertices A, B, C, D, E. We can plot them as well as by row wise as well as column wise. Always the diagonal elements are 0 in the adjacency matrix. So, we can take that. Then once A is adjacent to B, the value is 1. A is not adjacent to C, the value is 0. A is adjacent to D, the value is 1. A is not adjacent to U, the value is 0. Likewise, we can find all the values in the matrix. So, we get the adjacency matrix for the given graph G. Next, the definition of an incidence matrix. The G is equal to V, X be a P, Q graph. And V is equal to V1, V2 up to Vp and E is equal to E1, E2 up to EQ. The P cross Q matrix B is equal to Bij, where Bij is equal to 1 if Va is incident with Xj and 0 otherwise, is called the incidency matrix of the graph G. For example, we can take the 4 vertices V1, V2, V3 up to V4 and 4 edges E1, E2, E3, E4. We can plot them as well as by row wise as well as column wise. V1 is incident with E1, the value is 1. V1 is incident with E2, the value is 1. V1 is incident with E3, the value is 1. V1 is not incident to E4, the value is 0. Like this, we can find all the values in the matrix. So, we get the incidence matrix for the given graph G. One more example with the 4 vertices and 5 edges. V, W, X, Y are the vertices. E, F, G, H, J are the edges. V is incident with E, the value is 1. V is incident with F, the value is 1. P is not incident with G, the value is 0. P is not incident with the value H, that is the value is 0. P is not incident with the J, the value is 0. Likewise, we can find all the values in the matrix. So, we get the incidence matrix for the given graph G. Thank you.